So this will give us a very nice introduction into what makes special relativity sometimes confusing. It's because certain things happen that we don't observe in our human reference frame. So human speeds, human distances, human times. So uh, the idea of simultaneity of two events occurring at the same time for everybody is very important, and the order in which events occur is very important in order to determine cause and effect. Causes occur before effects. So if we're to understand how the universe is working, we need to be clear on when things are occurring and in what order they are occurring. Here's the setup. There is a railroad car that's traveling from the perspective of Ryan, an observer fixed to the ground to the right. Priya, his colleague, is standing exactly in the middle of the railroad car. So this was determined before there was any motion. That is, this the setup, right? The setup is Priya is standing right in the middle. There's a box right in the middle. The box has a sensor that is pointing to Ryan's right, what Ryan identifies as the right, and a light sensor, and there's a light detector inside the box separate that is pointing to what Ryan identifies as the left, right? So left and right. There's a firecracker on each end. Again, Priya is in the middle, the box is in the middle, firecracker on each end, equally spaced, or I should say obviously spaced. The firecrackers will make a burn mark on the ground. And let's see, if the detector on the right it receives a signal from the explosion, a light signal from the explosion first, the detector will flash green on the top. If the detector on the facing left detects a wave first, the light from the left firecracker explosion first, it will the detector will go red, and then if the two waves arrive, the two light waves arrive simultaneously, it will also report red, it will flash red. So here's let's see, here's a summary. Ryan is on the ground, the cart's going to the right, Priya standing in the exact middle, the box has the two detectors, right first green, left first green, simultaneously red, and that is our setup. So here's what happens in Brian's frame. The explosions are simultaneous. Ryan detects that the two explosions occur, the two firecrackers go off at the same time. So he is standing there, and his detector, his personal detector says these two things happened at the same time. So that's his observation. Later, he notes the burn marks. He notes the burn marks on the ground from the explosions, makes a measurement, and learns that he is standing midway between the two explosions, and consequently, he is standing midway across the midpoint of the cart, so he is standing directly across from Priya when the explosion occurs. The explosions occur. He detects simultaneity, and then he learns that he was right there in the middle of the cart. So what we then can see that at the moment of the explosion, light spheres, or light rays, if you wish, are traveling in Ryan's frame of reference. The right one is sending a wave that is going in all directions, but he sees a wave front moving to the right, and on the left, a wave front is also been initiated and is moving to the right. So the wave front, there's a wave front coming in from a wave. Where's my camera here? Wave front coming in. Wave fronts are coming in from both directions. Okay, since the cart is moving, in Ryan's reference frame, Priyanka and the box are moving towards the wavefront that's coming from the right, and will therefore observe that the light from the right first, and the signal will be green. Ryan will then watch the cart move away, and the two signals will arrive simultaneously. So summary, right? Travels at the same speed, light travels at the same speed. An assumption from relativity at all inertial reference frames in a vacuum, right? The light is coming from two fixed points, right? Fixed points. The burn where the explosion occurred, at an instant of time. And Ryan can see that Priya and the box are moving to the right, and so are to the right. And so the box detects light coming from the right first, signals green. All right, so let's now think pre-relativistically and say, well, Priyanka's going to see the two light beams also. They're going to explode simultaneously in her reference frame. Everything happens the same everywhere. If we assume that the explosions occur, right, the instant, right, now Priya's in a fixed reference frame from her point of view. She's not moving. Ryan is moving past her to the left. And if we assume that those explosions occur simultaneously when she passes Ryan, then, those 2 points are fixed in her reference frame at the end of the cart, and the light will reach Priya and the detector consequently at the same time. And also note that from Priya's point of view, then she will say, if that's the case, that Ryan will have observed the light from the left first, and then the light from the right will catch up, right? So they're moving simultaneously. If they are moving simultaneously, the two light waves reach her in the box at the same time, and then according to Priya, then she would say the signal box is going to be red, right? Because for her, she's just standing on the cart. It's not moving in her reference frame. Everything else is moving, right? It's moving to the left. She's like, I'm just here. We're not moving. Everything else is moving. And so if we assume that because Ryan saw them simultaneously and they're equally spaced from the box and from Priya, they will happen simultaneously. That's it. Well, again, we made that assumption that they have to. It makes perfect sense that that's what would happen. Ryan reported the flashes occurred simultaneously. His detector, he was halfway, right there next to Priya, right across from Priya. He measured and concluded that based on measurements, and the light is coming at him at equal speeds. Now that is not classical relativity. That's special relativity. Is that because certainly sound does not behave that way. That if sound is moving away from you, if it's moving toward you, it acts differently. We'll get that next quarter. But light does not. That is the assumption of special relativity. Light is going to come at the same speed. All right. How to resolve this? Well, this is actually what happened first in Priya's reference frame. In Priya's reference frame, the firecracker on the right ignites first. Okay, she is fixed. It's fixed. Nothing is moving firecracker-wise, Priya-wise. It blows up. It explodes first. She sees the light wave striking her first, and the detector first, right? And then later, the left firecracker goes off, right? The left firecracker goes off. And now remember, there's two things going on. The light wave from the right is moving towards Ryan. He's moving away. It's heading over there. It's had some time to to get over there. And then later, the second firecracker goes off just perfectly synced so that, because it's now closer. Ryan has gotten closer to it. So it's happening later. It has less to travel, but the wave from the left and the wavefront from the wavefront, no, this way, from the right and the wavefront from the left, they had different distances to travel, but they reach Ryan simultaneously. Right? They reach Ryan simultaneously. But that only occurred when the one on the right, or the one we've called on the right, that, from Ryan's view is on the right, that went off first. And then the one on the left, from Ryan's perspective, went off later. It actually went, right? So again, in one reference frame, events occurred simultaneously, and in another reference frame, they did not. One firecracker went off and then another. And that's the only way that the detector, which is, just a detector, can report the same thing. So it's not a matter of perception. It's not a matter of, well, blah, blah, blah. That's what I thought. It simply is the only way that only one reality exists. So Ryan does observe simultaneity. Priya says, oh yeah, I see. They arrived simultaneously at Ryan, but they didn't occur simultaneously and in Priya's frame of reference. Anyway, so well worth, all of this is just straight in the text and you can go through it. These are just word for word. Think about it. The text does say, this may seem troubling, but it's because we're assuming certain things that are not what we expect. And number one, that light traveling from both directions is traveling at the same speed, even though the source is moving. We don't expect that. Right? This would be analogous to going to the airport and going on the moving sidewalk, and people on the moving sidewalk would be traveling at the same speed as people that are not. Walking at the same pace. It's like, that's not our experience, right? That's Galilean relativity, but this is special relativity, where the speed of light is always the same for every inertial reference frame in a vacuum. Anyway, there's relativity.